All right, let's talk about why we'd like to reset a qubit. Well, when you're doing a quantum operation, it's always good to know where you're starting. So if I have a register, I want to begin by resetting. So I know this qubit's in 0, this qubit's in 0, all my qubits are in 0. And then sometimes we say we start with the register of qubits that are initialized. We can write them as a bunch of zeros here that have been reset. And so we always assume we start in some sort of fiducial state that has been reset to something we know, so that we know when we operate we get out what we expect to. This is one of David DiVincenzo's criteria for a quantum computer. But other than that, it can be very useful for a lot of algorithms. For example, there's something that's very important in quantum computing called phase estimation. Phase estimation. That's behind a lot of the algorithms that can give you exponential speedups. So phase estimation pretty much works like this. I have a bunch of qubits that have been arranged in a 0. And I need to control a register of qubits that are started in some other register psi. And what I'm going to do is each one of those qubits is going to be coming down and doing a controlled unitary on each one of those registers. U to the n. I guess these need to be longer here. That's u to the, let's see, n plus 1 or 2n something. Well, it's always some u into some power. I think it's binary. Something like that. And if you look at this, we have a bunch of different qubits that are all starting the 0 state. That's all well and good. The thing is if we have the ability to reset the qubit mid-circuit, then we don't need all these different zeros here, and we can actually do this a lot more compactly. So with reset, we can get a circuit that looks like this, where I just have a single 0. It's not even a register, but it's a single 0, and then I have my register I'm acting on called psi, which is a register, and I can do a single controlled U right here, and then I can reset it, which we put by just this 0 symbol right here. And then, before operating on that register again, I know this is in the 0 state, so I can just go and then do my U squared, and then I can reset again. And then I can do my U to the 2n, or whatever it is. And this way, I can treat all of my ancilla qubits with just a single qubit instead of a register of qubits. So one of the important things about reset is you can do quantum algorithms more efficiently. My name's Nick Braun, and that's why you want to reset qubits.